Good morning. Today's lecture, we will continue with the sound topic. We will talk more about the hearing and the intensity levels, and we'll introduce the logarithmic scale and measuring the intensity. And next lecture, we'll be wrapping up the acoustic unit. So in last lecture, we introduced the beats, and we have seen how beats happen due to the slight difference in the frequency between two interfering frequencies. And the wider the difference in the frequency, the more the frequency beat would be. So for example, here, this is going now to take us to this example where we can discuss it and explain it further. The traces below show beats that occur when two different pairs of waves are combined. For which of the two pairs is the difference in frequency of the original waves greater? The time scale are the same in both images. We can see here in pair number one that the pattern is repeated more than pair number two, which means that the beat frequency for pair number one is greater than the beat frequency for pair number two. In this case, the answer would be 1, because the number of the repeated patterns represents the cycles per unit time, and here we have the same unit time, which means that the cycles for pair number one is greater than the cycle for pair number 2. So we have here an intensity of approximately 1 watt per meter squared is considered as the threshold of pain. So 1 watt per meter squared is the threshold of pain. At a distance of 190 meters from a jet taking off, the intensity is measured as 0.1 watt per meter squared. What is the closest you should be to avoid pain? We will first calculate the power from the example given to me, which is at 190 meters from a jet taking off. I have a measured intensity of 0.01 watt per meter squared. So let's do this. So we have here I equals to P divided by 4 pi r squared, which means the power is I times 4 pi r squared, which is P equals to I, the intensity level is 0.01 times 4 times pi times 190 squared, and then the power is 4.536 10 to the power 3 watts. So this is the power generated by the jet. Now we need to calculate the new distance. In this case, I have I2 equals to, or let me put this one, pain equals to P divided by 4 pi r squared. And in this case, r squared is P over 4 pi I pain (4.536 10 to the power 3 divided by 4 pi I pain is 1, and in this case r squared is and R is 19 meter. So now this is my new R. 19 meter. So the answer to this question is B. We said that human hearing's frequencies range goes from 25 hertz up to 20 kilohertz, typically. We also said that the common threshold of hearing is 1 10 to the power minus 12 watts per meter squared. And also now we have seen that the threshold of the pain is 1 watt per meter squared. Since the range is so huge, we will be using the logarithmic scale in order to uh, reduce this huge range. And as we said earlier, it will be more useful to use the threshold as the reference in our decibel measure for the intensity level. So we will introduce what's called the beta, where beta is 10 times the common logarithm, which has a base of 10 for the intensity level divided by the intensity threshold. So our reference is the threshold. Let's look at a few examples that we may encounter in our daily life. So we said that the threshold of the hearing is 0. Why 0? Because we are dividing 1 to the power minus 12 by 1 to the power minus 12, which is the reference, and this is going to give me 1. That the logarithm of 1 is 0. Let's look at other sounds and other noises. Uh, the threshold of pain is around 120 dB. Noisy street, for example, 80 dB. Average whisper at 1 meter is around 20 dB. We will see how we can calculate those numbers, but every increase in one order for the common logarithm times the 10 is going to result into a 10 dB increase. We will look at a few examples, but before we do this, let's refresh our memory with how to calculate the logarithms in general. We have x that is equal a to the power y, so the base here is a, and I took the logarithm of x with the base being a, then I will be interested in the power of the a. So if my logarithm here is to the base of the 10, which is the common logarithm here, then this one is 1 to the power 1, and in this case, this equals to 1. Now for this one, the next one is logarithm, of course, for the base 10. 100 is 1 times 10 to the power 2. Then it will be this power, so this is 2. Again, same thing for 10,000, which is 1 to the power 4. The answer would be 4. Here, the same base, 10, 10, then the answer would be the power. Now, what happens if it's a number that is not with a base 10? Then the answer would be find the equivalent for 27, which is 10 to the power 1.431, and the answer then would be the 1.431. So let's look at those rules. The product rule, if I have a product and I'm taking the logarithm for this product, then it will be the logarithm of the first, the logarithm of the first plus the logarithm of the second. The quotient rule, if I am dividing a number by another number and I'm taking the logarithm of this fraction, then it will be the logarithm of the numerator minus the logarithm of the denominator. Power rule, again, this is logarithm with a base of 10. Then in this case, it will be the power times the logarithm of 10 for the number A. Now let's look at this example. In this example, we have three saxophones that are providing sounds. Each saxophone is providing an intensity level of 75 dB. The question is, what is the intensity level of the resulting sound? So each one is producing 75 dBs. I need the total. How much is the total? In this case, we can solve it in two ways. The first one is find the intensity for that one saxophone. So here, beta is 10 logarithm of I divided by I naught. I do have beta to be 75, which means I over I naught is 10 to the power 7.5. Now the new intensity is 3 times of this, then I tot over I naught would be I over I naught times 3. In this case, I tot over I naught as 3 10 power 75. Beta nu is 10 logarithm of 75. Beta nu equals to 79.8 dB. So this is one approach. So the second approach is beta nu equals to 10 logarithm of I tot divided by I naught, and we know that I tot is 3 I divided by I naught. Beta nu is 10 logarithm 3 plus 10 logarithm I over I naught. We know this 75, then beta nu is 4.7 or 4.8 plus 75, and the answer is 79.8 dB. The second example here, two sounds differ in intensity level by 45 dB. What is the ratio of the intensities of the two sounds? In this case, if we have those two sounds that have different in intensity by 45 dB, then I can write the following. I have 10 logarithm I2 over I naught minus 10 logarithm I1 by I naught equals to 45 dB, which means that I have I2 10 logarithm I2 over I naught divided by I1 over I naught equals to 45 dB. Or here I naught would cancel, assuming we have the same threshold. Then I2 over I1 equals to 10 to the power 4.5. And in this case, I2 over I1 equals to 31.6, 10 to the power 3 watts per meter squared. Intensity levels. A pop-up ad has an intensity level that is 20 dB more than the intensity level of the original video you were watching. How does the intensity of the ad compare to the intensity of the video? Again, the difference is 20 dB here. 10 logarithm I2 over I naught by I1 over I naught equals to 20 dB. This means I2 over I1 equals to 10 to the power 2, and this is 100. So the difference is 100 times. C. Last example for this lecture. Beth sets her car's audio oscillator to 300 Hz and the speaker volume to a level which she judges to be 60 dB. The intensity of the sound in the vicinity of her ears is 1.2 to the power minus 4. So we have I equals to 1.2 to the power minus 4 watts per meter squared. We need, what is Beth's hearing threshold? We need her I naught. Apparently her I naught is not 1 to the power minus 12. We need to find her I naught, her threshold for the 300 Hertz. If we know the density level beta, we know beta is 60 dB. So how do we solve this? So beta is 60 dB and 10 logarithm I over I naught is 60. I know I, which is 1 to the power minus 4, so 10 logarithm 1 to the power minus 4 divided by I naught equals to 60, which means that 1.2 to the power minus 4 divided by I naught equals 2, divided by 10, 10 to the power 6, 1.2 10 to the power minus 10 watts per meter square.